Okay, guys, I'm gonna go through the review exercise we need to do in preparation for our well design test on Monday. This first part is pretty straightforward. We need to use one equation, which is pressure equals rho GH, or if we need density, that equals to pressure divided by gravity and depth. Density in this case is given by kilograms per meter cube, pressure in kPa, depth in meters, and gravity we are using 0.00981. Using these formulas we can fill up the tables. I'm gonna leave the values here for a bit so you can check the results. Also, our instructor uploaded the results for this exercise in D2L. After we calculate these values, we need to figure out which ones are related to pore pressure and which ones are for fracture pressure. On the estimated pressure table, we already have it separated into pore and fracture, but on the first table we don't. So looking at the pore pressure first, our values for the first table will be the static gradient, the build-up, and the kick. Now that we have those pressure points, we go to the pressure versus depth graph. The first thing we need to do here is to plot the normal pore pressure line using the normal pore pressure relation of 10 kPa per meter. We can then plot the normal pore pressure line, which will be the base for our pore pressure curve. After this, we plot the pore pressure related pore pressure points in the graph, and we can now deviate our pore pressure line from the normal one, passing it over the points we just plotted. We can now go back to the tables and get the points related to the fracture pressure. We also plot those into the graph, and now we can build our fracture pressure line based on those points. After the pressure versus depth that graph is done, we go back again to the tables to get the values for density related to the pressure we just used on the other graph. And we can now build our density versus depth graph. We trace a baseline which with the density related to the normal pore pressure, which will be 1019 kilograms per meter cube, and put the densities related to the pore pressure measurements there too. We again can deviate the curve from the normal pore pressure line so it can honor the points. The next step is to plot the fracture points and draw a line over them. That's our fracture pressure line for density. Remember that the value of the last point in the density, this point, the last point in the density graph has to match the pressure point for the pressure graph. Check that by calculating it using pressure equals rho GH. And if the point is off, fix it in one of the graphs, either the density or the pressure. We need to add a 40 kilograms per meter cube trip margin to both curves on our density graph. So we add those lines, and after doing that, we can start designing our casing. And the starting point should be the total depth of the well, in this case 3,680 meters. So our production casing will start here on a bottoms-up method, and we draw a straight line up until we reach the trip margin for the fracture. We then go straight left until reaching the trip margin. Till reaching the trip margin for the pore pressure, and that's the end of our intermediate casing. We can now go straight up if we don't breach the fracture trip line again. We can take it to the surface. In our exercise, we will have to violate the trip margins in lower depths, so we will only have one intermediate casing. I will end this video here, and in the next one we will calculate the depth of the surface casing, the casing parameters that are missing in the casing table, and we'll do the well diagram. See you there.